Hello and welcome to Empowered Learning. This is part 2 of the Rational Expressions video series. And so we want to go ahead and start off here by doing some examples with adding or subtracting rational expressions that have like denominators. So we'll do this first, and then we'll talk about what we do whenever we have to add or subtract rational expressions that do not have like denominators. And so just like with fractions that have unlike denominators, we first have to find a least common denominator first, and then after that form an equivalent rational expression or equivalent fraction, and then from there we add them together. So that will be what we will focus on in this particular video. Alright, so to start off with, we see that for our first example here, since we have like denominators here and we're doing subtraction, all we need to do is subtract the numerators, and we see that 3a minus a is just 2a, and then from there we just reduce 2 over 4 to 1/2, and thus our answer ends up just being a divided by 2. Similarly here for example 2, since we're just doing subtraction, we will just subtract numerators, and notice how I'm putting the second expression in the numerator in parentheses so that we can remember to distribute our understood -1. And then from there we will reduce. So we know that 9 minus 6 is 3, and -4y plus 1y is a -3y. And then from there we have a common factor of 3 in the numerator. And then the 3 is reduced to 1. And the result, I'll just write it up here, is just 1 minus y, all that divided by y. Okay? And that will be the final answer for that. For our next example, we want to do the same thing. Here we need to write this second expression here in parentheses, and this is just to remind ourselves that we need to distribute our understood -1 to all terms. So we'll have x squared plus 3x minus 3 minus x squared minus 4x plus 7. And then all of that will be divided by x minus 4. And so now we start to combine like terms. So x squared minus x squared gives us 0. So that cancels the 0. 3x minus 4x will give us a -x. And -3 plus 7 gives us a +4. Okay? And so from there, if we note that a -x plus 4 is the opposite of +x minus 4, so if we factor out a -1 out of the numerator, you see that we'll just have -1 times x minus 4 over x minus 4, and of course these reduce to 1, so our answer just ends up being -1 as the final result. For the next example here, we see that we have a rational expression with a common denominator of 2x squared plus 3x minus 2, and you notice here we're doing the same thing. If you've noticed, I've already sort of put this in parentheses and distributed, and hence why the signs have changed here, here, and here. So from that point, we combine like terms, which is what happens here. And then after that, we factor both numerator and denominator out, and we find that we have a common factor of x plus 2, so that reduces to 1. And our final answer just ends up being 4x minus 1 divided by 2x minus 1. Okay? To do a similar example here, but with addition, Notice that here, since we just have plus, no need to put anything in parentheses. We can just combine like terms here. So 2x squared plus x squared is 3x squared. Negative 8x minus 9x is a negative 17x. And a negative 4 minus 3 is a negative 7. So we have that over 2x squared plus 7x plus 3. And we'll do what we can to see if we can factor out numerator and denominator here. So for the denominator first, we'll have 2x and x plus and plus. And then the factors of 3 are just 1 and 3. So we'll put 3 here, 1 there. For the numerator, kind of do the same thing. See if anything factors out. Do 3x here, x there. Since we have a minus minus here and here, we know one of these is going to be plus, one of these is going to be minus. I'm going to put the subtraction sign here just because whatever factor I need to put over here needs to be the bigger one, and I'll put plus here. So the factors of 7 are just 1 and 7. So here, if I put 7 here and 1 there, we'll see if this works out. So we have 21, negative 21x plus 1x. That would be a negative 20, which doesn't work out there. Going in the other direction, that wouldn't work either. So it seems like this 3x squared minus 17x minus 7 will not be able to be factored out. Okay, because again, if we looked at it from a factor by grouping standpoint, we're trying to think of what are the factors of negative 21 that add up or subtract to be negative 17. We can't find it. Okay, so in that instance, when we see that happen, what we can do is just kind of leave everything as is, because we know we're not going to have any common factors. So most that we can really do with it is what we see right here. Okay, not much else that we can possibly do. So we'll just get rid of that, and our answer will just remain like that. Okay, for our final example here, we know that if we have common denominator a plus b, excuse me, and we add these together, we have the sum of 2 cubes, and we know that the sum of 2 cubes factors out to be a plus b times a squared minus ab plus b squared. And of course, both these have a common factor of a plus b, so that reduces to 1. And now we have a squared minus ab plus b squared. Okay, so this is how we actually add rational expressions whenever we have like denominators. Now, in the instance where we have unlike denominators, we will need to find the LCM, which is the least common multiple for each rational expression. And so in general, when we talk about adding and subtracting rational expressions, we're talking about finding the LCD. And so the only difference is D is denominator, whereas LCM, the M stands for multiple. And multiple is just a more general term. When we use least common denominator, it's specifically used for the case of whenever we're trying to add or subtract rational expressions. So we want to find the least common multiple for these particular numbers or expressions. The least common multiple is the smallest number that all of these can divide into without having a remainder. So what do I mean by that exactly? Okay, so to make sure that I'm very clear and very plain on what I mean is this. If we had a number and divided it by 8, and had a number and divided it by 20, and had a number and divided it by 28, what would be in the box here is the smallest number that all three of these would divide into without having a remainder, meaning that we would have an answer without a remainder, basically. Now, how we figure that out is we need to take each of these expressions here, and this is just one way to do it. We can take each expression and factor it into its prime factorization, okay? And then we find from there the row, and what I mean by row is for the 8, the 20, and the 28, the row that has the most of each prime factor, or each different prime factor, and then we circle all those, okay? So for 8 is 4 times 2, which is the same as 2 times 2 times 2. 20 is 4 times 5, which is the same as 2 times 2 times 5. And 28 is 7 times 4, which is the same as 7 times 2 times 2. So we see that the prime factors that we have here are 2s, 5s, and 7s. So we want to circle the row with the most amount of 2s, most amount of 5s, most amount of 7s. So for 2s, we see that we have 3 2s here. For 5s, we see that we only have 1 5 there. And for 7, we see that we only have 1 7 there. Okay? So our LCM would just be all these multiplied together. So 2 cubed times 5 times 7, which will basically be 8 times 35. 8 times 35, that's 0, carry the 4, that would be 280. Okay? So the LCM here would be 280. So 280 is the smallest number that 8, 20, and 28 can divide without having a remainder. Okay? And so we'll use this particular concept whenever we're wanting to add rational expressions that have unlike denominators. Okay. For the next example, we have 12a cubed b squared and 18a b to the 5th. And so as you see for each of these, I've broken these down into its prime factorization. And then from there, you see that I have the prime factors of 2, 3, a, and b. Okay. And what I mean by prime factor is a factor that is only divisible by 1 in itself. Okay. And so we see that the first row had the most amount of 2s. Second row had the most amount of 3s. The first row had the most amount of a's. And the second row had the most amount of b's. And so when we multiply all that together, we see that 36a cubed b to the 5th is what our least common multiple would be. Okay. So for example, C, if we factor out z squared minus 25, that's z minus 5, z plus 5. If we do 5z minus 25, we know that that has a common factor of 5. So it's just 5 times z minus 5. And if we have 5z plus 25, sort of the same thing here, just z plus 5 instead of z minus 5. So we have z plus 5, z minus 5, and 5 for our prime factors. So we see that here, no row here has more than 1 z plus 5, and no more than one row has 1 5 in it. So we're going to circle all of this. Okay. And so the z minus 5, we will go here. So we're taking care of all those. And so our LCM now is just 5 times z minus 5 times z plus 5. Okay. Which if we multiply that all out, it would just be 5 times z squared minus 25, which would be 5z squared minus 125. Okay. For our next example here, we have our trinomial expression 16x squared minus 8x minus 3, and then 4x squared minus 7x plus 3. And as you see for each of these, I factor these out, and I see that I have prime factors of 4x minus 3, 4x plus 1, and x plus 1. And we see that there's only no more than one 4x minus 3, no more than one 4x plus 1 in any row, and no more than 1 x minus 1. So multiply all those together, and this is what our LCM would be, or if we were using this in a particular situation where we were trying to add or subtract rational expressions, this would be an LCD. Okay, but for right now, this should just be LCM. All right, so now that we have that, we can now add and subtract rational expressions. So if we look here, we see that we start off with just basic fractions. So first fraction has a denominator of 52, the other one has a denominator of 40. So we break down doing prime factorization to figure out what the LCD would be in this case. And we see that after breaking it down, it ends up being 520. So from that point, we form equivalent fractions. So 7 over 52 equals to what over 520? Well, we know 52 goes into 520 10 times. 10 times 7 is 7. So that's how we get that. Of course, here we know that 40 goes into 52 13 times. So 13 times 3 is 39. So hence we have our equivalent fractions, both with a denominator of 520. And so we just rewrite and then add the numerators, and we get 109 over 520. Okay. In example 2 here, notice that we have a squared b, which is just a times b, and ab squared, which is just a times b. And so we have a's and b's. The row with the most amount of a's is this one. Row with the most amount of b's is this one. So our LCD is just a squared b squared. Okay. So if we form an equivalent fraction here, we know that the one thing that is missing on the first one is b. So we divide, we multiply the first rational expression by b over b, and then the second one by a over a. And so when we do that, we end up having 2b minus 3a all over a squared b squared. And so we know that because here we know that the b times b gives us b squared here, and the a times a gives us a squared there. Okay. All right, for our next example, we see that we have a minus b and a plus b. A minus b and a plus b are called prime expressions because the only thing the only factors that a minus b and a plus b have are itself and 1 respectively. So in this case, we multiply them together to find out the LCD. This is very much like if we were doing 1/3 minus 1/5, and we were wanting to add that particular, those two particular fractions together. We know that 3 and 5 are both prime numbers, so therefore the LCD would just be the product of those, which would be 3 times 5, which is 15. Okay, so this example sort of mimics that. Okay, let's get rid of that. Move on. So now that we know that this first fraction needs to be multiplied by a plus b in numerator and denominator, and the second rational expression needs to be multiplied by a minus b divided by a minus b. Okay, so here we know that when we do that, we just have a plus b divided by a minus b times a plus b for the first term. And then we have, for the second term, we have 2 times a minus b divided by a plus b times a minus b. Okay? And then from there, when we add both of these together, we see that we just write it with the common denominators, or with the equivalent fractions rather, or equivalent rational expressions. And then from here, we just add the numerators together. Okay, so combine the A's together, combine the B's, and then once that's done, we see that our final answer is just 3a minus b divided by a squared minus b squared. Okay, and a squared minus b squared is just another way of saying a minus b times a plus b. Okay. All right. Similarly, for example D here, we know that x plus 2 and x minus 2 are prime, so we need to multiply the first rational expression by x minus 2, multiply the second by x plus 2 over x plus 2. So if we do that, distribute the both terms here, that will be 5x minus 10 over x plus 2 times x minus 2. And then the other one would be 3x plus 6 all over x plus 2, x minus 2. Okay. And then from there, we would just combine like terms. So 5x, 3x is 8x. Negative 10 plus 6 is a minus 4. And from that point, it's not much else we can do with that. We could factor out a common factor of 4 if we wanted to. Won't really change much, but we could do that if we wanted to. And that would be our final answer there. All right, for our next example, you'll see here that first thing that we need to do is figure out what x squared plus x minus 12 is, okay? And if we factor that out, see that we have xx here, one has to be plus, one has to be minus, and the factors of 12 that have a difference or sum of 1 would be 4 and 3. And so since we want the middle coefficient to be positive, we're going to put the larger factor by the addition sign, so that'll be 4. Put the 3 by the subtraction sign. Okay. And so then from there, we kind of see what's going on here. So we see that the one thing that's missing is an x minus 3. And of course, that means our LCD is going to be x plus 4 times x minus 3. So that means we need to multiply numerator and denominator by x minus 3 here. So if we do that, that gives us 6x minus 11 minus 5 times x minus 3, all that over x plus 4 times x minus 3. Okay, and then here if we distribute, let's try that again, distribute, then we end up getting 6x minus 11 minus 5x plus 15, all that over, let's try to do that again. Didn't turn out so hot. 6x minus 11 minus 5x plus 15, all that divided by x plus 4 times x minus 3. And then we just reduce. 6x minus 5x is a positive 1x. Negative 11 plus 15 is a positive 4. See, once that's done, we have a common factor of x plus 4. And of course, our final answer ends up being just 1 over x minus 3. Okay. So moving on to the next example here, we see that in this case, we have to factor out both denominators to kind of see what's going on. So we factor the first one out, which is a difference of 2 squares. Factor the second one out. and we see we have a common factor of x plus 2. Okay, so the thing that's missing is an x minus 2 for this particular rational expression and an x minus 5 in this one. So as you see, I'll go ahead and take each one of these expressions here. So this is the first one, this is the second one, and I rewrite it in its factored form, see what's missing, and multiply numerator and denominator by that. So that's what I'm doing here. Multiply through, and this is what I get for the equivalent rational expression for the first one. Do the same thing for the second one, factor it out. I see that I'm missing x minus 2 in the denominator for the LCD. So that means I have to multiply numerator and denominator by that. Multiply through, and this is what I get. So after that, we see that the way that we can rewrite these first two expressions here is by rewriting it this way per what we got here and here. And then after that, we just distribute our understood -1 to both of those, and then just from this point here, we just combine like terms in the numerator, and we get a -3x divided by x plus 2 times x minus 2 times x minus 5. Okay. All right. And so at this point, we will conclude this particular video, and we will start with part 3, solving rational equations.